Hello, this is question 2 from the 2007 MAT. This is for all candidates. They've given us some function of x here, which also varies with n. N is a positive integer. X is any real number. So what's going on? This is a function of x. All right, we've got a quadratic in x, and the coefficients are changing with n. So that's fine. We've got our x squared, we've got our x, we've got our x to the power of 0 term at the end here, and all these coefficients vary with n. Write down f3 of x. So that's just putting n is equal to 3 into this. So 2 minus 8 is minus 6x squared plus 6x plus 3 squared is 9. Right, that's fine. Find the maximum value of this. So our maximum value is going to be, well, let's do f dash for subscript 3 of x is going to be equal to minus 12x plus 6. So we've got a maximum at x equals a half. So the maximum value, therefore maximum f subscript 3 of x equals f3 of a half, and that is going to be equal to minus 6 over 4 plus 6 over 2, so that's 3, plus 9, so 12 minus 1.5, 10.5. For what values of n does n of x have a maximum value as x varies? So we need, if it's going to have a maximum value, we're talking about negative quadratics. So maximum value when the coefficient, x squared coefficient, is less than 0. So that means, therefore, we've got 2 plus minus 2 to the power of n is less than 0. N we already know is positive, and it's an integer. So that has already restricted things somewhat. It can't be equal to 1, though, because we'll just get 2 minus 2, which is not less than 0. And can it be any other value of n? No, it can't. We can't have even values of n, because even values of n will turn these minus 2's into positive numbers. So we need n is odd, and n is, well, either not equal to 1 or greater than 1, whatever way you want to put it. It's the same thing in the context of this question. I've just noticed here, note you are not being asked to calculate the value of the maximum. Well, yeah, I should hope not. And we haven't. Right, so that is part 1 of the question. Part 2, write down f1 of x. So f1 of x, there is no x squared term in that because we've got 2 minus 2. Then we're going to get 4x plus 1. Then we need to, all right, we're nesting them up then. So f1 of f1, f1 of x, that is going to be equal to 4 lots of 4x plus 1, which gives us 16x plus 5. And then they want us to do it again. So f1 of x, 1, 2, 3, close brackets, 4, 16x plus 5 plus 1. 64x plus 21. Okay, find an expression simplified as much as possible for, right, we're just going to keep on nesting these up k times. K is some positive integer. So what have we got here? We've got 4x, 16x, 64x. Yeah, we're just multiplying that up 4 times. By 4 each time, I should say. So we've definitely got 4 to the kx. That's one bit that we've got for the first term. And then we've got 1, 5. What's the next thing going to be? So 21. What we're actually doing with these numbers, I'm going to take that 21, I'm going to multiply it by 4 and add 1 on. Okay. So is that a simple pattern? Multiply it by 4, add 1 on. So we're going to end up with 85. But the thing that's changing is that multiple of 4 that we're getting there. So with our 85, what's our sequence? 1, 5, 21, 85. So we got gaps of 4, 16, 64. Right, so that's what we can work on. Oh, I can see what the pattern is now, but now I've started on this. Let's do the geometric series approach, make it a bit more rigorous. So yeah, we've got this happening. So we got 1, then we got 1 plus 4, then we got 1 plus 4 plus 16, then 1 plus 4 plus 16 plus 64. So we got this series that we're adding up on this. We're doing the sum from, oh, we've used n already and k. So let's go, I don't know, r equals 1 to k of 4 to the r minus 1. We're having to put in the minus 1 because for our first term, we're starting with 1. Then we're adding on 4 for the second term. So 4 to the power 1 when r is 2. So we need to take 1 off. But that minus 1, we want to take outside of our sum. Otherwise, it's going to mess up our summing up this series. So we take a quarter out, the 4 to the minus 1, and then go r equals 1 to k of 4 to the power of r. So we can now stick this into our sum to n is a r to the n minus 1 over r minus 1 in inverted commas, because of course all these r's and n's are not the r's and n's that are currently being used in these equations. So I don't want to get muddled up on those. So we've got that quarter, which is outside, and then we've got our first term, which is 4. Then we've got r to the n in inverted commas, so that is going to be 4 to the k minus 1 divided by 4 minus 1. So the 4 and the quarter are going to cancel, and that leaves us with 4 to the power of k minus 1 over 3. Yeah, which is what I ended up spotting in this sequence. You can see if you take, so for the first term, start with 4, take 1 off to make it 3, divide by 3, you get 1. For the next one, take 16, take 1 off to get 15, divide by 3, you get 5. So you can see this pattern. So you might have got that by inspection, looking at these numbers here. But in the end, our answer is this. So we've got 4 to the power k x plus 4 to the k minus 1 divided by 3. Right, that was much tougher than the rest of the question. Is it going to get similarly difficult in the final part of the question? Write down f2 of x. Right, that doesn't bode well because this is going to be a quadratic, isn't it? So f2 of x, we have got 2 plus 4, so that is 6x squared, then 5x, and then 4. So 6x squared plus 5x plus 4. Right, this looks as though it's probably going to turn into something horrible because they now want to nest this forever. f2 is applied k times. It's a polynomial in x. Oh, what is the degree of the polynomial? Right, okay, we don't mind this because we're starting off here. So when k is equal to 1, we've got x squared. When k is equal to 2, so we do this again, we're going to put x squared in and we're going to square it. We're going to have x squared and then we're going to square it because we're sticking it back into here. That's going to be the degree of the polynomial. That is going to be x4. And then x is 3, we'll have x to the power of 4 squared, which is x to the power of 8. So we're going 2, 4, 8, 16, etc., etc. So the degree of the polynomial is going to be 2 to the power of k. Right, that was nowhere near as bad, that last part, as I thought it was going to be. The work here was in the second part of the question, doing this geometric series, unless you happen to spot it just by inspection. But that's a nice question to get us kicked off on the long questions in 2007.